Hi everyone, welcome back to our YouTube channel and today's question is maximum average subarray 1. So we are given an integer array nums and consisting of n elements and an integer k, and we have to find a contiguous subarray whose length is equals to k and that has the maximum average value, and we have to return that value, and if there is any calculation error less than 10 raised to power minus 5 will be accepted. Okay, so as we can see in this example, 1, 12, minus 5, minus 6, 50 and 3. K is 4. So any subarray of size 4 will be our answer. So we just have to check, since this 12 minus 5 minus 6 50 is giving the maximum average sum. So yeah, we have to return that. Since in the second example, k is 1 and the size of the array is also 1, so we just have to return the 5. And yeah, so let's just go to the intuition part to better understand this approach. Yeah, so let's just start with the intuition part. So as we can see, 4 size array will be, it can be this, it can be this, or it can be this. So we have to find basically contiguous one. Okay, that is main part. So contiguous is continuous element. So only these three, 1, 2 and 3, these three possible solutions we can have. And if we can check 1 plus 12 minus 5 minus 6, so and we have to divide it by 4 of the elements, so it will be 13 minus 11, that is 2. Okay, 2 by 4 is 0.5. So this will be first possible solution. Second possible will be 12 minus 5 minus 6 plus 50 divided by 4. Okay, 12 minus 11 is 1 and this is 51. 51 by 4. Okay, so it will be 12.75. Okay, and third will be minus 5 minus 6 then plus 50 plus 3. Okay, and it will be divided by 4, so it will be 53 minus 11, that is 42 divided by 4, and this is 4 10.5. So maximum will be this one out of 3, so our answer will be 12.75. So how we can find this solution? So there's a generic sliding window technique, okay, which is used in most of the solutions where this sub-array type questions are given. So what that is, if we are given an array, let's just say 1 2 3 4 5 6, and there is a window size that is given, let's just say k is equals to 3. So we will take first this one and find our answer, and after that we will find all the windows whose size is k, that from where we can find our answer. Similarly, in this example we can do that. So how we'll do that? First we just find, let's just copy that example. It is 1 12 minus 5 minus 6, 12 minus 5 minus 6, 50 and 3. Okay, so in the first step what we'll do, we will take this size of window. Okay, this size of window, okay, and we will find our sum. Okay, sum, because average we can find anytime, divide by k will be the average, so the only thing that matters is this sum. Okay, because divide by 4 is common, so we will find our first sum, that is 13 minus 11 2. Okay, after that we will start from this. First we'll find this sum. Okay, now we'll start from here. Okay, now what we'll do, we will take this window. How we can take this window? We will subtract this one. Sorry, we will take from this position, right? So we will subtract this and add this. Now we can get our answer. Okay, so we will subtract 2 minus 1 plus 50. So this is 51. Okay, as we have got this similar here. Now after that, what we'll do, we will go to here, and we will update our maximum basically. Okay, earlier maximum is 2. Now maximum will be max of, okay, max of current sum is 51. So max of sum and maximum. Okay, and this will be 51 comma 2. So it will be 51. So our new maximum is 51. Okay, now our window will be updated. So we will subtract this 12 and add this 3. So sum is equals to, earlier sum was 51. Now we'll do minus 12 plus 3. So 53 minus 12, that is 41, as we have find above. So we will update our maximum. Check if we can update max of sum comma maximum. Now it will check, earlier was 51. No, sorry, current is 41. Earlier was 51. It will not update. It will again give 51. And when we come out, we will just check, that is, we have to return, okay, maximum divided by k. Okay, so this will be our answer. And if we can see this thing, we are just iterating over this array. Okay, this array. Okay, here. So the time complexity will be big of n. Okay, and the space complexity will be, since we are just using variables, the sum, maximum, not anything, so our time space complexity will be big of 1. Okay, so yeah, let's just start with the coding part to better understand this approach. Okay, yeah, so yes, now we can start. Okay, so let's just have the size of the array in some variable nums size. Now we can take a long variable to store the sum for now. So first we have to go till 0 till k size. Okay, for the first window. Now we just add all the variables in the sum. So it will be nums of I, right? So this will be our first window. Okay. Now we take another variable maxsum and store this sum in it. Okay. Now we will go from kth I is equals to kth till n. Okay. As I have mentioned in the example, we will go from kth element to nth element to find our maximum answer. So what first we have to do? We just have to add. Now the updated sum is, we just need to subtract the nums of I minus kth element, okay, and need to add ith element. Okay, now we need to update our maxsum. Okay, maxsum is equals to max of sum and earlier maxsum. Now we get our maximum. Okay, now if we come out of the loop, we have found our maximum sum of the subarray of size k. Now just have to return our answer by finding the average. So it will be maxsum divided by k. Since we need to return it in the form of double, we just typecast it into double. Okay, think we have got our answer. Just try to run it. Yeah, it is working fine for one of the test case. We will find for all the test cases, sample test cases. Yeah, it is working for all of them. Let's just try to submit it. Yeah, it is working for all the test cases. Yeah, thanks everyone for watching. In case you do like this video, please do subscribe our channel. And if you have any questions, please do ask in the comment section. I will try to answer all of them. And if you have any alternate approach, please do share it. Yeah, thanks everyone.